Hey, you're still sticking around. That's good. I didn't bore you with all my talking, but yes, in this video, finally, we're going to write some Python code. Holy moly, thank God, I thought that was gonna last forever. All right, so what is our first program going to do? Well, let's create a very, very simple function. And probably the first thing any programmer learns to do, to print our own name. So in here, once you have your REPL.it set up, or remember, you can also use glot.io, we're simply going to write print, and then you see over here that it gives us some information, but all we want to do is write brackets, a quote, so you can do double quotes here or a single quote, and just type your name. And if we click run, on the right side, we've just written our very first Python program. Very exciting. But what's happening here? Well, let's look at everything. First of all, if you're confused why my thing is dark and yours might be light, it's because if I go to settings, I've set my theme to light or to dark. I prefer the dark version. But you can change some of your settings. You can change the font size if you want. Based on when you watch the video, this website, the look might be different, but most of the settings should be the same. We see that we have a main.py, which is the Python extension. Any file that has a .py or py is a Python file. So what we've just written here on line 1 is a program that prints, in this case, Andre Nagoy, or in your case, your own name, and we've written it to this file. Now, REPL.it takes this file, already has this interpreter for us. It runs this piece of code, gives this source code of main.py to the interpreter, and runs it right here on our right side. If you look over here, we're using Python version 3.6.1, and down below, we see that, we have Andre Nagoy printed. That's awesome. So this is our code running. Remember this diagram. All we've done is we have our main.py, where we wrote print Andre Nagoy. We gave it to the interpreter that the REPL already provides for us. That interpreter takes our code, converts it into bytecode, and here it'll say Andre Nagoy, and then it runs it in the CPython VM, which was on the right side that we saw. And it finally prints our name because it tells the machine, hey, we want that text printed. So that's what we're seeing here. This is the CPython virtual machine essentially running this code and telling this machine, hey, I want you to print this. All right, but this isn't very exciting. I mean, let's make this program a little bit more dynamic. For our first program, we want to do something more impressive than just print name. So I'm going to teach you another thing we can do in Python, and it's called input. Now in here, I can say input, and you see that Repl actually gives me some information saying that, oh, I have this. You can just click here. And this input over here, well, what can we do? This input is going to prompt a user, and if I hover over it, you can see how it's giving me some information. But input simply gives us a way to capture information. So let's say, what is your name? And if I run this code, we see that we have our Python code running, and it's asking me what is my name with this cursor here. So I can actually type something here. I can say Andre. And if I hit enter, well, there you go. I've just typed in my own name. Nothing that exciting, right? But this is where code becomes interesting, because we can store this information on our computer. So again, these are things that we're going to go over in detail in our basics Python section. But just to write our first code, let's assign this to memory. That is, let's say that name equals whatever is the input of what is your name. And then finally, we can just print the name. So remember, the interpreter is going to take this first line. It's going to ask, what is your name? I'm going to type something. That typed information is going to get assigned to name. And then finally, we print name. Remember, an interpreter takes line by line, converts code to bytecode, and then finally runs it. So let's give this a try. I'm going to click run. All right, what's your name? My name is Andre. Did you see that? I typed in my name, hit enter, and then it printed out Andre. So for the final feed, let's greet. So we're going to say print hello, and then plus name. Now, don't worry about the syntax. We're going to go over it. But all we're doing is saying hello and then adding our name to the end of this. So let's see what happens. If I run this and say, what is your name? My name is Andre. And I hit enter. I get hello, Andre, but no spaces. So let's add a little space. Hit run again. For the fourth time, my name's Andre. And it says, hello, Andre. There it is, our first Python program. Now, it's not very exciting because it is our first program. We're just learning the steps here. But I hope, because we've covered some of these topics ahead of time, that this isn't just pure magic, right? You understand that this is source code. This is main.py that we give to an interpreter that runs our code line by line and then executes our program. In this case, our what is your name program. How cool is that? This is just the beginning. We're gonna get more and more advanced here. See if you can play around with this. We don't know that much about Python yet, but I hope this gets you excited because, well, there's a lot more coding coming along. I'll see you in the next one. Bye-bye. Whenever you start to learn Python, it's unavoidable that you'll encounter this topic of Python 2 versus Python 3. So what is this all about? And it's a very important topic. Now, first of all, Python is created by a human, right? As a matter of fact, it was created by this person right here. His name is Guido. Now, a programming language is always evolving. It's not like somebody creates a programming language, it's perfect, and that's it. No, all programming languages are constantly being updated. Just like on your phone, you constantly get software updates. Well, a programming language is constantly evolving to make it better and better because nobody gets it right the first time. And by the way, this is a great video that I'm gonna link to. You can check it out in the resources. Now, Python was created in 1991 by this gentleman, and it was actually created with the name from Monty Python, which was a British comedy group. But like I said before, the language is always evolving. And in 2008, Guido decided that, well, Python version 2, which has been used for a very long time, had some things that he and the community wanted to change. So in 2008, they decided to create Python 3, a new version of the language. Here was the tricky part. You see, when you update software, let's say on your phone or even on your laptop, you expect things to keep working, right? Updates are usually good, they're improvements. But some of the features that Python 2 had, they didn't like, or they wanted to change completely. So Python 3 introduced what we call breaking changes. That is, if you updated to Python 3, remember the Python interpreter, the C Python translator that we've been talking about? Well, As soon as you updated that, your Python 2 code wasn't really going to work. It's like updating your phone and then all of a sudden all your apps stop working. That doesn't sound very good, does it? That's pretty much what happened in 2008. Most companies that wrote their code in Python version 2 just kept Python version 2 because, well, for them to upgrade meant that they had to go through their code line by line and make some changes. Now, these changes weren't that significant. For example, I'll link to some resources, but don't worry, these are topics that we're going to cover throughout the course. But different things wouldn't work. For example, the print function, which we've learned about, in Python 2, it didn't have the brackets. It looked like this. And Python 3 used the brackets. So all the code that had print like this would break. Now, the differences themselves aren't that big. I mean, you can read through them and we'll talk about this in the course, but overall, you can learn them in a day. That's why when we learn Python, most of the time we're learning Python 3, but you can use the same knowledge with the older version of Python. Now, you may see some Python version 2 code out there for companies that haven't upgraded, but it's now what we call legacy. That is, come 2020, it's going to stop receiving security updates. So the community, Python community as a whole, is saying, hey, everybody start using Python 3 because we're going to stop maintaining Python 2. So we're going to learn the most up-to-date version 3 in this course, but we're also going to touch on some older topics that Python 2 covers, just in case you encounter them when you work for a company that perhaps still supports legacy code. But as I mentioned, the whole community as a whole is moving towards Python 3. This website, for example, shows you how many big packages, popular Python packages, which we'll talk about, support Python 3. In our case, there's only 4 popular packages that don't support Python 3. So what I'm saying is Python 3 is the way to go. It's the way of the future. That's what we're going to learn in the course, but I want you to be aware of the historical context. And one thing to be careful of when in this course you're searching for answers, or maybe I have some exercises that require you to Google things. For example, if we go to the Python documentation, which is the reference of how, well, what the programming language does, you'll see that you can choose the versions here. And you always want to go with the latest, but you might find some answers online that still use Python version 2. So you want to make sure that when you're searching for answers that you don't encounter any legacy code. Like I said, 95% of the time it's mostly the same, but you usually want to keep current with the language. It has the most community support, most up-to-date, most secure language. So, just a quick note about Python 3 versus Python 2. When you hear the word Python, people are generally just talking about both Python 3 and Python 2. And if you remember, in our REPL, when we created our first program, you see that you're using Python version 3.6. This is the default standard version that REPL comes with. So right away, we know that we're using Python 3. Awesome. It's up to date. It's new. The whole community is behind it. Well, most of the community is behind it. So we're all good to go. I'll see you in the next video. Welcome back. I wanted to answer this question that I get a lot of, even from professional developers that have been in the field for years. So I want to tackle this question really quickly right now. Why are there so many programming languages? Why can't we just have one language that does everything and everybody's happy and we don't have to worry about learning so many programming languages? And here's the thing. In your career, you don't need to know 5, 10, 8 languages. No, you can be a really successful developer, programmer, with just one language. Just finding that speciality of yours. And programming languages like Python, Java, and JavaScript offer a lot of opportunities where you don't need to learn another language. But why are there so many languages? If we go to Wikipedia, these are the list of programming languages. And if you're looking through here, you should be intimidated because there's no way in your lifetime you're going to learn all of these. And, well, you won't. Most likely you're going to learn 1, 2, maybe 3 languages in your entire lifespan or career as a programmer. And different programming languages are good for different things. Just like we have different tools to, let's say, build a house. You can't just build a house with a hammer. You need different tools that are good at different things to assemble what you want. So it's impossible to build one ultimate language when we have so many applications, so many mobile phones, so many computers, so many devices like cameras. So you have low-level languages that we've talked about, like assembly code or C. And then we have higher-level languages like Python and JavaScript. Now, here's the thing. Python is usually slower than languages like C++ or C# or even Java. And we don't need to get into technical details here, but I do want to tell you about a trade-off. You see, you don't really want to write Python code for low-level systems and hardware interactions. If you're taking this course, well, you're probably not even interested in that field. You see, Python, although slower than some languages, is good at one thing and does this really, really well. That is developer productivity. Because Python is so easy to learn, or at least is very similar to the English language, it's become really, really popular for developers to be productive and write code really, really fast in less lines than something like C. So a print hello world, for example, in Python would take, well, just 1 line. But all languages have their different strengths. For example, if you want to build an app on Android or an iOS device, well, you're not really going to use Python. But if you want to do machine learning, maybe you want to build a web server, maybe you want to do data visualizations, build scripts that process thousands of Excel files. Well, in that case, you're going to use Python. And we're going to cover what different things you can do with Python and what Python is really, really good at in this course as we explore different projects later on. But keep that in mind. The reason there's so many programming languages is that every programming language excels at some things and, well, doesn't do so well at others. It's all about trade-off. There is no ultimate language. And if a programmer tells you, hey, my language is the best language, well, they're probably junior developers that don't know what they're talking about. Everything is a pro and con. Everything has a trade-off. And as programmers, what really good senior programmers do is being able to detect what these pros and cons are and what tool to use for a specific problem. Something that throughout this course, I'm going to try and teach. I'll see you in the next one. Bye-bye. Let's do our first exercise. And this exercise is going to be really easy for you to skip, but I do recommend that you actually do it. I know it's not coding, but it's important because you'll learn that teaching somebody a topic actually helps you learn. So this is the exercise. Based on the videos that you've watched, how does Python work? But don't think about it in your head. I want you to talk to somebody. I want you to teach somebody how Python works. So the first thing you're going to do is go to our community, our Discord community. We have lots of people here. We have about 1,500 people online right now, plus some alumni, plus some star mentors. Well, there's a lot of people. What I want you to do is go to the Programming Buddies channel, if you haven't already, and find a buddy. And with that buddy, whether that person is taking a Python course or taking a JavaScript course, it doesn't matter. Just say, hey, can I spend maybe 5 minutes teaching you how Python works? And see if you can explain it to them, how it works just like you've learned. And then, after you've done that, I want you to go find a friend or a family member that has never done programming before and see if you can explain in simple terms how Python works. That is how Python gets written as source code. We use this translation service called an interpreter to run this code and then, well, spit out some instruction for our machines. I kind of gave away the answer, but you know what I mean. I want you to practice teaching somebody this, because by understanding these fundamentals, it's going to help you learn more and more and understand how things work underneath the hood as we get more and more advanced. Right. First little exercise. It shouldn't be too hard. I'll see you in the next video.